This question is from GATE 2014 Mechanical Engineering paper set 4, question number 53. A cylindrical riser of 6 cm diameter and 6 cm height has to be designed for a sand casting mold for producing a steel rectangular plate casting of 7 cm by 10 cm by 2 cm dimensions, having the total solidification time of 1.36 minutes. The total solidification time in minutes of the riser is dash. Let's write the given information. So for riser, it is given that the diameter is 6 cm, its shape is cylindrical, and its height is 6 cm. So D and H are equal to each other. That's what we see here. For casting, we have a steel rectangular plate. Dimensions are also given, which are, if we take in the order L, B, H, we have length as 7 cm, breadth as 10 cm, and height as 2 cm. We'll take thickness to be 2 cm. It has a solidification time of 1.36 minutes. So let's write T for casting is 1.36 minutes. Let's solve this one. Now we know that for any body, its solidification time is directly proportional to the square of the ratio of its volume by surface area. So T is directly proportional to volume by area V by A whole square. We can write this ratio for both riser and casting. So we'll do it for both of them. For riser, the volume will be, let that be VR, pi by 4 D square into H, because it's a cylinder, and D is given equal to H here, so it is pi by 4 D cube. Now its surface area can be calculated assuming that all surfaces are involved in cooling. So the curved surface area is pi dH plus the surface area of the top and bottom surface together. So it is 2 times pi by 4 D square. This turns out to be pi into D because D is equal to H again. So pi D square plus pi by 2 D square, which is nothing but 3 by 2 pi D square. This was for riser. Now let's do it for casting. So for casting, we have again volume is simply 7 into 10 into 2, which will be simply 140 millimeter cube. Let this be VC. And here also this area to be AR, so that it is denoted for riser. And for casting, we'll keep it as VC and AC. So VC turns out to be 140 millimeter cube. Surface area AC will be the surface area of the rectangular plate, which is nothing but 2 into length into breadth plus breadth, thickness plus thickness into length, adding the surface areas of all the surfaces individually. This turns out to be AC equal to 2 into. After substituting L, B and T, we have the value of surface area as 208 millimeters square. So let's calculate the solidification time for each of them. For casting, it is given. For riser, we need to find it out. For both the cases, this relationship is valid. T is directly proportional to V by A whole square. So we can take the ratio of this relation for both riser and casting. So we'll take T for riser, solidification time for riser by solidification time for casting is equal to V for riser by A for riser whole square upon V for casting by A for casting whole square. Let's substitute and find out solidification time of riser, which will be equal to VR by AR, which is nothing but pi by 4 D cube by 3 by 2 pi D square. So after simplification, we get this as D by 6 whole square divided by VC by AC, which is nothing but 140 by 208 whole square, into solidification time for casting is 1.36 minutes. So substituting D as 6 cm, we get numerator as 1 and denominator is 0.673 whole square. So further we have 1.36 upon 0.673 whole square. This turns out to be solidification time of riser as 3 minutes. Let's go back and fill in the answer. We have total solidification time in minute of the riser is 3. To learn more about riser design, you can refer to the NPTEL video Casting Riser Design from the course Fundamentals of Manufacturing Processes. This course is by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering Department of IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.